Hi everyone, let's solve this problem. Implement trie prefix tree. A trie or a prefix tree is a tree data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure such as autocomplete and spell checker. Implement the trie class, initialize the trie object, and then we also have to implement insert method that inserts word into the trie, search which returns true if the string word is in the trie that is was inserted before, and false otherwise, and starts with returns true if there is a previously inserted word that has prefix, and false otherwise. So let's try to create a trie data structure. So let's follow the instructions which we already have here. So this is the root, and then we have initialized our trie. Then we want to insert apple. So there is no word with starting with a as of now, so we are going to insert a. Then we are going to insert p, l and e, and we'll also ensure that this is marked as end of the word. So I'm just marking it with red to end of word. Then we have search. We are searching for apple, right? Let's see. We found a, then we found p, then we found p again, then we have l again, we have e again, and we also know that this is the end of the word. That means apple as a word exists in the trie, so we will return true for this case. Then we will again move forward with search. Search has app so we will start with a, we have p again, we again move to p, but this is not the end of the word, so we will return false for this case. Then again we have starts with app. So now we just have to check if there is a word which starts with app. It does not have to be an actual word. So I check a, then p, then p. All three characters exist, so I will just return true for this use case. Then I have insert app. So I will check if a is already present, yes. P is already present, yes. Again p is already present, yes. But the only difference is that I will mark this as end of word now. And again I will be searching for, next thing is searching for app. So I found a, p, that means I found the word because there is a marker end of word as well, so there was a word inserted already for this. This is how we check. So basically trie in this example is nothing but it contains only all lowercase English letters. So in this case, any tree, for example, will have a, b, c until z, all small characters, and then there can be again a, b, c, all possibilities. So whatever possibility is available, we just create a root for that. This is how it works. Now let's try to write the code for this. So first of all, we'll create a root with object children. Let's create a map for it instead of creating a array. If we create array, it will be 0 to 25 because there are 26 English lowercase alphabets, but we are creating a map. And then end of word will be boolean. Currently it will be false, and this is a object, so this is how it should look like. Cool. Now insert. When I am trying to insert, first of all I will get the current root, then I will iterate over every character of word, and I'll check if current children has the character if the character is not present, we'll have to create the character, the node. So how are we going to do? We are going to just set character and we are going to create the similar children structure for the node. And one second, let me format it. That is all. Then if the children already exist, we just have to move to that particular character. So what I'm trying to say is, initially we inserted apple. When we were trying to insert app again, we did not create a again, right? We just move to the next letter because we know that this is already been created. Okay, and then we are done, and at the end of the word we have to mark current dot end of word as true. That is all we have to do here. Now let's do the search will be again similar. We are getting the current for every character of the word. If the children does not have this character, return false, else towards the end of return current dot end of word. Okay, again starts with is also same, except that we don't have to check for the end of the word, but we just have to return true. Let's try to run it. Let me check what is the issue. This root has this particular set character current dot children. It should be possible. Okay, this is a mistake which we made, children. So yeah, it should work now. Yeah, let's submit it. It works. Now let's also understand the time and space complexity of this. Time complexity of this solution is basically for every method we are kind of iterating over all the letters of that word. If we consider the length of word as n, it is going to be big O of n, and space complexity of this is nothing but the size of the trie, nothing but all the characters that are present inside this particular trie. So if we consider there are t characters, then the size of the space complexity is big O of t. So I hope the solution is clear. Thank you.